What we're going to do to measure the results of our winding is we're going to use this little LC meter. It's available from almost all digital electronics as a kit. It's a great kit. It's fun to put together. They're $99.95, and for a home brewer they're invaluable as far as winding your own inductors and things. This is a really neat little meter. We just take and turn the power on. It comes up, it calibrates itself against a standard that it has inside, and it's all ready to go. And we're going to tell it we want to measure inductance, and it says not an inductor. The reason it says not an inductor, the leads are open. If we take and hook the leads together, because an inductor has continuity, then we simply take and we're going to zero it out by pushing the zero button. And see, now it's saying it's 0.001 microhenries. And we'll connect our inductor into the circuit here. And it says we have 2.166. Remember, the calculations for that number of turns said it was going to be 2.06, so we're about 1/10 of a microhenry high. Well, part of the thing is we have extra leads here. You would think, well, that's not going to make much difference, but let's take a look and see how much difference it makes. So we got 2.166. I'm going to write that down because I'll forget it. I've cut off the leads and re-tinned them. I'm going to re-zero the meter, and we'll connect up our inductor. So the leads are just about the right length now to hook up to the printed circuit board. And I measure 2.05. That's pretty close, considering the value for that number of turns was 2.06. So I'll buy that. That's great. I've always been amazed at how close these wound ones actually come out to the predicted value. So we're less than 1/100th of a microhenry off from the predicted value. I've wound another core using the brown wire. This is the non-heat strippable wire. Got them spaced fairly evenly. Got the right number of turns, I hope. We'll find out if I didn't, because it won't measure the right value. So next thing is we'll go ahead and strip the tails out and measure the value. This is really hard to show, but what I've done is I've placed the wire down on a flat surface on top of my vise, and I'm just using an X-Acto knife to scrape the enamel off, and I'll rotate it around, and every time I twist it I don't see bare copper again, so I'll just keep doing that until I've scraped the enamel off all the way around. There's probably easier ways to do this, but this has worked for me, and it's relatively easy to do. It's harder. I think you can even see the shiny part once I get the enamel off. Since you're dealing with X-Acto knife, you want to be careful not to put too much pressure, because you don't want to cut the wire off. It's not a big deal here where the leads are this long, but when you do the final strip back near the body, if you cut the wire, it'll be too short to go on the board, and you're either going to have to take one turn off. See, now you can see both the powder down here, and you can see that it is stripped off. Okay, we have it hooked up. we're measuring a value of 2.166 microhenries. And remember, we've got these extra lead lengths here. This just goes as a good demonstration of why you use as short a lead length as possible. You wouldn't think that couple inches of wire would add a tenth of a microhenry, but it most certainly does. So let's go ahead and I'll shut the camera off. I'll trim the wires back to installation length, restrip the insulation off, and we'll remeasure and see how it measures. It's a lot harder working with these short leads now, and plus we want to strip right up close to the body of the inductor. And if you don't get the insulation off, you won't get the solder on, and there won't be a real indication of it unless you ohm meter out your connections that you have an open circuit other than the circuit doesn't work. Then you'll cuss me out because you'll say, I wound the inductor just exactly the way he showed, but it doesn't work. Well, it'll work if you take and get the right number of turns, get the right core, and get the insulation stripped off. I think that's good for that side. Said it's really difficult to do with and get it right back to the body of the inductor core. You could see where if you accidentally cut the wire off, you're going to be too short. So make sure that you don't press too hard with whatever means you're using to strip the enamel off. I think that's good. Now I'm going to take and get the ends spaced out on the core back, get it back the way it's supposed to be, and snug the leads out. And we should be ready for a remeasurement. We're going to measure our inductor now and we'll see how close we came out. We'll zero the meter. Connect it in. And we measure 2.13 microhenries. Remember, our calculated value was going to be 2.08. Our other inductor measured out 2.06. This measures out 2.13. So this is within 0.05 of a microhenry. The other one was within 0.02 of a microhenry. So we were successful in winding our 2 microhenry toroids. In this video, we've wound 2 of the 3 inductors that are needed for the input filter. The literature called out for them to be 2 microhenry. We ended up with about 2.15 microhenry or so. Now, we don't need to be exact because we have adjustment here with the 22 picofarad variable capacitor. So they should take up the adjustment for the extra inductance that we actually have. If you don't have the test equipment to measure these with, what you can do is if you get the T37.6 core, use a number 28 wire and put 26 turns on it with 2.1 microhenry inductors, and that will be close enough.